In Section 5.1, we'll examine the relationship between moles of reactants and moles of product in a balanced chemical reaction. We'll use those relationships to calculate the moles of one substance in a reaction given moles of another substance. We can do this because stoichiometry allows for the calculation of quantities of any substances involved in a chemical reaction from the quantities of the other substances. Stoichiometry relies upon the ratios of substances in a chemical reaction, requiring that we start with a balanced chemical equation. Let's look at an example. We can interpret this reaction in one of two ways. When you're first learning chemistry, you're more likely to think of this reaction in terms of two atoms of solid phosphorus reacting with 3 molecules of chlorine gas to form 2 molecules of phosphorus trichloride. We need to shift this perspective now to think of the coefficients as moles of a substance instead of atoms, molecules, or formula units. When we do this, we see that we can use Avogadro's number to get back to atoms, molecules, or moles if needed. We also see that we can use moles of a substance from a balanced chemical equation to move between moles of A to moles of B and vice versa. Let's see how that works. We can use this balanced chemical equation to write mole-to-mole relationships between any two substances. For example, we can relate 2 moles phosphorus to 3 moles chlorine, or the reciprocal 3 moles chlorine to 2 moles phosphorus to describe the ratios of reactants. We can also relate moles of phosphorus to moles of product, 2 moles phosphorus per 2 moles PCl3, or 2 moles phosphorus trichloride to 2 moles of phosphorus. And we can do the same for ratios of chlorine to product. 3 moles chlorine are equivalent to 2 moles of PCl3, and 2 moles of phosphorus trichloride are equivalent to 3 moles of diatomic chlorine. Let's see if you can write these ratios to solve the next example problem. Given 3.18 moles of oxygen, how many moles of aluminum do we need for the reaction? When solving any problem in chemistry, start with what you're given, moles of oxygen in this case. The unit you want to get rid of goes on the bottom of the mole-to-mole relationship, and the unit you're moving towards goes on the top of the ratio. Keep in mind that the ratio always needs to list equivalent quantities, in this case 3 moles of oxygen and 4 moles of aluminum. Solving for moles of aluminum, we get 4.24 moles of aluminum to 3 significant figures. Here's one for you to try. Some solid potassium chlorate is heated, which causes it to decompose into solid potassium chloride and oxygen gas. How many moles of oxygen gas are produced? We're not given a balanced chemical equation, so your first task is to write one. Next, use moles of potassium chlorate and its mole-to-mole relationship with oxygen to calculate the moles of oxygen produced. When you do the calculation, you should see that 0.1146 moles of potassium chlorate will decompose to release 0.1719 moles of oxygen gas to 4 significant figures. As always, I'll leave you with the parting thoughts of the authors.